Hi students, physics 5th episode, welcome TSAT channel. Here in bringing an electron towards another electron, the electrostatic potential energy of the system. See children, here the two electrons are there. Suppose here the electron, here the electron is there. Between the electron and electron, negative charge. Negative charge means repulsion. Due to repulsion, suppose one electron taking another side, here what happened? The work done value is increases. When the work done values increases, potential energy increases. Okay children, ఒక ఎలక్ట్రాన్ దగ్గరికి ఇంకో ఎలక్ట్రాన్ దగ్గరికి తీసుకొచ్చినప్పుడు సేమ్ చార్జెస్ల మధ్య రిపల్షన్ ఫోర్స్ ఉంటుంది. రిపల్షన్ ఫోర్స్ను వ్యతిరేకిస్తూ మనం దాని దగ్గరికి తీసుకుపోవాలంటే మనం ఎక్కువ వర్క్ చేయాలి. ఎక్కువ వర్క్ చేసాం కాబట్టి అప్పుడు పొటెన్షియల్ కూడా ఎక్కువ అవుతుంది. పొటెన్షియల్ ఎనర్జీ ఆఫ్ ది సిస్టమ్ ఇంక్రీజెస్. ఓకే, అండ్ హియర్ ఏ ప్యారలల్ ప్లేట్ ఎయిర్ కెపాసిటర్ హ్యాస్ కెపాసిటీ C. Distance of separation between plate is D and potential difference V is applied between the plates. Force of attraction between the plates of the parallel plate capacitor is you know that children, here that value, what is that here? The formula is Q is equal to, the formula Q is equal to CV square by 2D. This is the formula children. Here a parallel plate air capacitor has capacity C. Distance of separation between plate is D and potential difference V is applied between the plates. Here force of attraction between the plates of the parallel plate air capacitor is Q is equal to CV square by 2D. See that option here, CV square by 2D. Any option is there? Yes, the third option is there. This third option is correct. Okay, two metallic spheres of radius 1 centimeter and 2 centimeter are given charges of 10 to the power minus 2 coulomb and 5 into 10 to the power minus 2 coulomb here respectively. If they are connected by a conducting wire, the final charge on the small sphere is 2 into 10 to the power minus 2 coulomb. Here small sphere is 2 into 10 to the power minus 2 coulomb. A wire emits 8 joule energy in 10 seconds when a current of 2 ampere is passed through it. The resistance of the wire in ohm will be, here you see the formula in this, H is equal to, what is that H? Heat H is equal to 80 joule. Okay, 80 joule. Here a wire emits 80 joule and T is equal to how much? T is equal to 10 seconds. T is equal to 10 seconds. And here I is equals to the 2 ampere. Okay, here the formula H is equal to heat H is equal to P into T is equal to IVT, or this is equals to the H is equal to another formula I square RT formula is there. What will you find out that? The resistance value will find out that. Okay, what is the resistance formula? Calculate the formula. here substitute 80 is equal to 2 square into 10. Okay, 80 is equal to 4 into 10 into R. Okay, or 80 is equal to 40 R. Okay, or R is equal to 80 by 40. Therefore, what is the value? Here 2. Here which option? Second option. Okay, these formulas keep in your mind. And next, the resistance of discharge tube. The resistance of discharge tube is here non-ohmic resistance, children. Non-ohmic. That means this is not satisfy the here Ohm's law. What is the Ohm's law? At constant temperature, the voltage is directly proportional to the current. V is equal to Ri. This is discharge tube cannot satisfy the Ohm's law. Therefore, this is called as the non-ohmic. Okay. Therefore, the first option, that is non-ohmic, is the correct answer. Resistance of a discharge tube is non-ohmic. Okay. Which of the following acts as a circuit protection device? ఓకే, మనం ఇంట్లో ఫ్యూజ్ పెడతాం. ఎందుకు పెడతాం? ఇక్కడ సపోజ్ హై కరెంటు పాస్ అయింది అనుకోండి, సర్క్యూట్ డ్యామేజ్ అవుతుంది. అందు గురించే ప్రొటెక్షన్ పర్పస్లో ఫ్యూజ్ అనేది పెడతాము. దేర్ఫోర్ హియర్ ద ఫస్ట్ ఆప్షన్ హియర్, దట్ ఈస్ ఫ్యూజ్. ఓకే, ఇన్ దిస్ యూ సీ దట్ ద conductor is what? Conductor, easily electrons are traveling from one place to the other place. Okay. Inductor is also nothing but a resistance that opposes the flow of current. And switch, here on off switch కరెంట్ ఆన్ చేయడానికైనా ఆఫ్ చేయడానికైనా మనం యూజ్ చేస్తాం. కాబట్టి ఫ్యూజ్ అనేటటువంటిదే హియర్ ప్రొటెక్టివ్ డివైస్, గుర్తుంచుకోవాలి. Here, when 3 identical bulbs of 60 watt, watt is the unit of power, 200 volt rating are connected in series to a 200 volt supply. The power drawn by them will be, here when 3 identical, what happened here? See again question, when 3 identical bulbs of 60 watt 200 volt rating are connected in series to a 200 volt supply, the power drawn by them will be, here you know that power P is equal to what? What is the formula, children? P is equal to IV. Okay, and also V square by R. This is also V square by R. Okay, here you substitute V is equal to how much? 200 into 200 by R. Okay, and bulb power, what is the formula? Bulb power P is equals to the V square by R. V square by R. Okay, therefore here what you calculate here, power P is equal to V square by R, or R is equal to V square by P. This is the formula. Okay, here substitute, what is the value? Therefore here 200 into 200 by here 60. Okay, therefore here the power value 60 is given, cut it, 200 into 20 by 6. Okay, here this value you calculate, and therefore here R maximum is equal to 3R. Okay, therefore in this you substitute that R net resistance. What is the net resistance? That is the 3R. Okay, or 3 into 200 into 200 by what 6. That is a resistance value here 2000 ohm. Okay, therefore the power value you calculate that 200 into 200 by 2000. Okay, you calculate, this is 20 is the answer, 20 watt here, that is the option. And here next, a long straight wire carries an electric current of 2 ampere. The magnetic induction at a perpendicular distance of 5 meter from the wire is. Here the formula, children, which formula you apply? B is equal to mu 0 I by here 2 pi d formula you apply. Okay, mu 0 is equal to, you know that, what is the mu 0 value? 4 pi into 10 to the power minus 7 into, here in this how much current is passing? 2 ampere current is passing. Therefore 2 pi with the distance of, how much is distance given? 5 meter. Okay, 5 meter, 5 into 5. Okay, here pi get cancelled, 2 get cancelled. Okay, here that option is 8 into 10 to the power minus 6. If suppose you are calculated this one, 8 into 10 to the power minus 6, this is here, this is 10 to the power minus 6. This is the answer. Tesla is the unit of electric field, magnetic field, electric flux and magnetic flux. What, children? Magnetic flux. Magnetic flux is a unit of the here Tesla. Here that is magnetic flux. Where is that? Fourth option. Okay. Next question. An electron having mass m, and kinetic energy E enter in the uniform magnetic field. Here uniform magnetic field B perpendicularly, then its frequency will be. Here the frequency is, what is that? E by Q VB 2 pi m by EB by 2 pi m. This is the third option. Okay, children, when electron having mass m and kept energy E enter in the uniform magnetic field B perpendicularly, then its frequency will be, what is that? Frequency EB by 2 pi m. And here the magnetic field, next question, see the magnetic field at a distance or from a long wire carrying current 0.4 Tesla. The magnetic field at a distance of 2r is what? Here see, children, in this question magnetic field B dash is equal to mu 0 I by 2 pi, here R place you can write that 2R. Okay. Therefore, here shall I take that here 1 by 2 is a common? 1 by 2 is a common, that is mu 0 I by 2 pi R, mu 0 I by 2 pi R. Okay. Therefore, B dash new magnetic field, what is that? 1 by 2 into, here given the value, what is that? Here mu 0 I by 2 pi R, mu 0 I by 2 pi R is there na? Here this value is given what? 0.4 children, 0.4. Therefore, 4 into 10 to the power minus 1 by 2. Therefore, 2 into 10 to the power minus 1, that value 2 into 10 to the power minus 1 is what? 0.2. 0.2 Tesla is there. This is the answer. Okay, are you clear? General formula is that B dash is equal to mu 0 I by 2 pi R. But here the distance R from a long wire carrying a current. Here the magnetic field at a distance of 2R. At R place లో 2R substitute చేసాం. స్టార్టింగ్ వాల్యూ 0.4 ఉంది కాబట్టి దాన్ని సింప్లిఫై చేస్తే 1 by 2 into 0.4 వచ్చింది. ఓకేనా? దట్ ఈస్ 2 into 10 to the power minus 1, that is 0.2 Tesla. Okay children? And a Bohr magnet, magnetic moment capital M, magnetic moment capital M is cut into two parts of equal length. See this question. The magnetic moment of each part will be, here this is the Bohr magnet children, this is a Bohr magnet. Okay, this is a Bohr magnet into two parts, ఇలా 2 parts cut చేశారు. The magnetic moment each part will be, generally what is the magnetic moment? Capital M is equal to small m into 2L. Okay, magnetic moment capital M is equal to small m into 2L. ఎప్పుడైతే ఈక్వల్ లెంత్గా కట్ చేసినప్పుడు దాని వాల్యూ ఏం చేంజ్ కాదు కదా. ఓకే, therefore here that is magnetic moment, but the magnetic moment value is of m by 2, m by 2. Okay, here this is, you can take that m by 2. Tangent galvanometer is used to measure, tangent galvanometer is used to measure here potential difference, current, resistance and charge. See children, here I is equal to tangent galvanometer, I is equal to K tan theta is the formula. That means what you are determined that I movement, here I is the current, therefore tangent galvanometer is used to determine the small size of flow of current, current value no kanukuntam. Therefore the second option is correct. The magnetic moment of a diamagnetic atom is, here diamagnetic atom value is equal to 0 children, that value equal to 0. And next here nickel shows ferromagnetic property at room temperature. If the temperature is increased beyond Curie temperature, then it will shows the, what is the answer children? Here iron, nickel, cobalt is the ferromagnetic substances. when the ferromagnetic substances temperature is increases certain a temperature, that temperature is called as the Curie temperature. At the Curie temperature, here ferromagnetic substances are converted to the paramagnetic substances. Okay, therefore here fourth option is the correct answer. Here Faraday's laws are consequence of conservation of here which one? That is Faraday's laws are consequence of conservation of here conservation of energy, children. You know that here what is the Faraday's law? Induced EMF is directly proportional to the rate of changes of magnetic flux. Here that is a consequence of conservation of energy. What is the conservation of energy theorem? Say that energy cannot be losses, energy cannot be gain, but changes from one system to the another system. Okay, శక్తిని సృష్టించలేము, నశింపచేయలేము, కానీ ఒక రూపంలో నుంచి ఇంకొక రూపంలోకి మార్పు చేయవచ్చు. Okay children, and here next one, therefore which option is correct? Energy, conservation of energy. Okay, what is the self inductance of a coil which produces 5 volt? When the current changes from 3 ampere to 2 ampere in 1 millisecond, in 1 millisecond. Okay children, you know that self inductance. What is the formula? E is equal to L di by dt. This is the formula. Here induced EMF is directly proportional to the rate of changes the current. Here the proportional constant is known as L. Okay, we want to find out the L value. L is equal to E dt by di. Okay, here E value is given how much? 5 volt. When the here ampere 3 ampere to 2 ampere, that is the difference. What is the difference? 5 minus 2. Okay children, 5 here 3 minus 2, 3 minus 2, and in 1 millisecond, keep in your mind, millisecond means milli 10 to the power minus 3 second. Okay, what is the value? Calculate the value. 5 into 3 minus 2, 1 by 10 to the power minus 3, 10 to the power minus 3 here. Therefore this value 5 into 10 cube. 5 into 10 cube how much children? 10 cube means 1000. 5 into 1000, 5000. 5000 Henry. Is it any option is there? 5000 Henry? Here the first option. Okay. Here this formula is the most important. E is equal to L di by dt. Okay. An inductor may store here energy in. What is that? The first option is its electric field, and second option is its coil, third option is its magnetic field, fourth option is both in electric and magnetic field. Okay, what is that here? Which option is correct students? In magnetic field. Okay, in inductor may stored energy, it's a magnetic field, right? And here that is see children, in this at question a 40 microfarad, a 40 microfarad capacitor is connected to a 200 volt 50 Hz AC supply. The RMS value of the current in the circuit nearly. The first option is 1.7 ampere, second option is 2.05 ampere, third option is 2.5 ampere, fourth option is 25.1 ampere. Okay, here 40 microfarad connected. Okay, the RMS, what is that RMS? IRMS is equals to the IRMS is equal to formula what? V by X XC. Okay, capacitor is given XC, inductive reactance we want the value. Okay, therefore what is the XC value? What is the XC? First you find out the XC value. 1 by 2 pi FC children. XC is equal to, substitute 1 by 2 pi, frequency how much given? 50 into, see capacity value is given 40 into 10 to the power micro means what? 10 to the power minus 6. Okay, here this value substitute, then what happened? That is the reverse. Here V value 200 by 1 by something, these values also went to the up, 2 pi into 50 into 40 into 10 to the power minus 6. Okay children, you calculate this value here 2.5, this value is 2.5 ampere. Okay, that is 2.5 ampere where the third option is there. Okay, students, ఇప్పటి వరకు మనం ఏవైతే నేర్చుకున్నామో వాటిని బాగా ప్రాక్టీస్ చేయండి. ఓకే, డిఫరెంట్ కాన్సెప్ట్లో మనం ఇక్కడ అబ్జర్వ్ చేసాం, వీటిని బాగా ప్రాక్టీస్ చేయండి. ఓకే, థ్యాంక్ యూ.